Our next task, now that we know how to tell if two figures are congruent, is to determine if the two polygons right here are congruent to each other. So we're given 3 points for each polygon, Q, R, and S, so that'll make a triangle. Then T, U, V will also make a triangle. Before we determine if they're congruent, we need to graph them. So I have these graphed. Over here, we can see QRS and TUV. Now let's take a look at each of the sides. We notice that this side is congruent to that side. This one is congruent to here, and I can prove that by showing that this goes down 3 and over 1. This one also goes down 3 and over 1. We don't need to know how long it is. We could use the Pythagorean theorem if it asked us to, but all we need to know is if they're the same. So these go down and over the same, so they are congruent. This one is congruent to this side right here, and we can prove that by going down 3 and over 2, down 3 and over 2, so those must be the same. So these two triangles are congruent to each other. What transformation took one to the other? In this case, it's pretty simple. This just translated or slid over to here. So Q went to T, R went to U, and S went to V. How far did it slide? It went to the right. Let's count the units. 1, 2, 3, 4 units. And each one of those we can do 1, 2, 3, 4, and 1, 2, 3, 4. So this is a congruence transformation of 4 units to the right. It is a translation. So that's how we'll describe that. For our next example, we're going to take a look at something that is a little bit more complex. These two triangles right here are congruent to each other. We can see that EF is congruent to AB, DE is congruent to BC, and DF is congruent to AC. So these are definitely two congruent triangles. The complex part is how did we get from one to the other? You'll notice that it's upside down and flipped around. There are lots of ways to take a look at this. We can do it through rotations, we can do it through reflections, we can do it using translations. I'm going to do reflections and translations, but if you find one that works in a different way, that is awesome. So first we're going to take this and we're going to reflect it across the y-axis. I'm doing that because I want to flip it around so that this side, EF, is over on the left like AB is. So if we do that reflection, we can see that we get this triangle right here, and that side is on the left just like I wanted it to. Now it's upside down from here, so I need this diagonal line to go up on top. I'm going to reflect this now across the x-axis and flip it upside down. So we're going to take that shape, we're going to reflect it a second time, and we get that up there. So this is now in the correct orientation for what I need, but it's in the wrong place. So I'm going to slide it to the left, I'm going to slide it down, and it will match up with this. Let's watch that transformation happen. I'm going to take it and slide it to the left. Let's count the units. That was 1, 2, 3, 4, 5 units to the left. And we'll slide it down. And we have now proven that these two are congruent through transformations. So when it asks you to prove and explain your reasoning, you can explain this series of transformations. They might be more or less complex. You might need more or fewer transformations, but here is one example of one that's a bit more complex than before. Thank you.